Okay, on number 46, we're going to start by finding the eccentricity. My formula for eccentricity, this one's an ellipse right here. I know that because of that plus sign that's in between them. So my formula for the eccentricity is C over A. So with an ellipse, A is going to be the square root of the bigger one. So in this case, I know that A squared is 3,721. So let me grab my calculator and do the square root of that. So A is going to be 61. All right, so let me put my eccentricity over here. So it's going to be 61. All right, then to find C, since I'm working with an ellipse, I'm going to use A squared minus B squared equals C squared. So opposite sign here than you have here. So that's going to give me A squared, 3721, minus B squared, 121, equals C squared. So that's going to give me 3,600 right there is equal to C squared. So the square root of that, C, is going to be 60. So my eccentricity is going to be 60 over 61. All right, we're going to omit number 47. We didn't do any vectors with angles this time, so let's jump down here to 48. I'm going to find a vector equivalent to P, vector P. Actually, let's change this. And let's have it just say to find the magnitude of the vector P and the magnitude of vector Q. This will give us two good magnitude examples. So here's X and here's Y. So to find a magnitude, let's say I'm finding the magnitude of V, I'm going to do the square root of X squared plus Y squared. And that's a formula that you will need to know on the exam. So with P, that's going to be the square root of X squared, so 9, plus y squared, so negative 7 squared gives me 49. So the magnitude of vector P is going to be the square root of 58. You can leave that as a square root. We don't need to change that into a decimal. And then the magnitude of vector Q is going to be 9 squared. Negative 9 squared gives me 81. And 6 squared gives me 36. And if I add those together, that gives me the square root of 117. Okay, on 49, we're adding some vectors together. We're also going to multiply by this scalar. So let me start by finding out what vector 3 times u is going to be. So u with 4 is 12, and 3 times negative 6 gives me negative 18. And then I'm also going to add that to 2v. So let's double v real quick. That's going to give me 10 and 2. All right, so to add those together, to add vectors together, I'm going to add their x values, and I'm going to add their y values. So that's going to give me the vector 22 and negative 6. Okay, on number 50, I'm going to get into working with some matrices here. So I'd like to solve for x, y, and z to find out which one is not correct on this. So I'm going to use a matrix equation to help me with that. And since I've got 3 variables and 3 equations, I'm going to start off with a 3 by 3. And I'm going to put my coefficients of x, this one's a little implied 1 right here, in the first column. I'm going to put my coefficients of y in the second column. And I'm going to put my coefficients of z in the third column. Next, I have my variable matrix, so x, y, and z. And then over here, I'm going to have my constant matrix, and that's going to be these 3 numbers that I have right here, 16, 28, and 6. All right, so that's what my matrix equation looks like. So what I'm going to do is I'm going to put this matrix into A and this matrix into B. All right, so in my calculator, to get to my matrix menu, I'm going to go to second, and this little inverse right here, second matrix. And first I'm going to start by editing, so I'm going to go over and edit matrix A. And this is a 3 by 3 matrix, 3 rows and 3 columns. And I'm going to enter all of those numbers. And be sure you go back and check all of your numbers. One little negative sign can really knock off your whole answer. All right, let's go and enter B. So I'm going to do second matrix, and I'm going to edit matrix B, number 2. So this one has 3 rows and 1 column. So this one's a 3 by 1. And I'm going to put in my 16 and 28 and 6. All right, so now I'm going to go back out to my home screen because I want to do something with these matrices. And we don't divide over by a matrix. Instead, we take the inverse to move it over to the other side. So to find my answer, I'm going to type in A. So I'm going to go to second matrix. And now I'm going to use the names. So A. And then inverse is that same little button right there, inverse. And then I'm going to do second matrix. And I'm going to use the name of B right there. And so this is going to come out giving me a matrix that matches up with this one right here. So my x value is 3, my y value is 5, and my z value is 5. So back over here on my answer choices, y was 5, z was 5, and x was 3. So z is not 6, and so B is going to be my answer. All right, on the last page, on number 51, we're trying to find an inverse. So we just talked a little bit about an inverse. So let me go back in. I'm going to put this matrix in A, so second matrix, and I'm going to edit A. And this time this is a 2 by 2. I've got 2 rows and 2 columns. So again, make sure all your numbers are entered correctly. And I'm going to go back out to my home screen, so second quit. And then I'm going to put in second matrix, A. So I'm going to use that under the names menu, and then inverse, and then push enter. Now that's a lot of mess. I don't really want to write all of that down. So a little trick for you, you can type in math, the math button, and frac just like you would on a normal decimal, and it will change that matrix also into some fractions for you. So it's a little easier to write down, and probably more what an answer choice would look like. So that one, and 4 over 13. Okay, on number 52, again, I'm going to enter this one into A and this one into B. So let me go to second matrix and edit A. And that is a 3 by 3 matrix. Oops. It's over. Negative 4. 1, negative 4. So again, let's check our numbers and make sure you get them all in correctly. Again, one little negative sign will make a difference. So second matrix, and let's edit B. And this time B is also a 3 by 3. Very good. And I'm going to go back out to my home screen, and I'm going to type in second matrix and A, and then times, and I'm going to put in second matrix B. That'll multiply A and B together for us. So that's going to give me 11, negative 1, and 17, 15, negative 4, and 15, and negative 17, negative 4, and negative 22. Okay, and in my last question, they're asking me to solve the system. So a couple of different ways to look at this solve the system. We could just solve for y, then it'd be easy enough to solve for z, and then we could work with x right here on this one. But since we're working with matrices, let me go ahead and set up a matrix equation. I am working with x and y and z on these, and I've got 3 equations. So I'm going to do a 3 by 3 system. So let me start with my x's. When I don't have an x, I'm going to put in a 0. So no x on the top one or on the bottom one. Then with my y column, I'm going to have 4 and 4 and 1. And then with my z column, I have no z right there. I have negative 2 on that one. And then I've got a 1 on that one. So if you don't have an x, y, or a z, fill in 0 as a placeholder. And then I need my constant matrix over here on this side. So that's going to be negative 20. And negative 15 and negative 9. All right, so I can enter that one into A and this one into B. So second matrix, and I'm going to edit A, and it's still a 3 by 3 matrix. That way you can see it. So that's going to be 0, 4, 0, and 1, 4, negative 2, and 0, 1, and 1. And again, check your matrix. And second matrix, I'm going to edit B, is now a 3 by 1. And check your negative signs and everything. And then I'm going to go back to second quit, and I'm going to enter A inverse B. So second matrix A,